Alright, so this is number 24, and it's another one of the geometric series problems, and it's asking if it converges or diverges, and if it does converge, what to. So again, in yellow I've written down the formula. The one thing you might notice is that it's giving us a problem starting at 0, and the formula calls for starting at 1. Now to fix that, we can just do a slight adjustment. Because we want the first term to be in the numerator, all we have to do is write it like this: r to the n equals 0 to infinity. And that way, when we plug in 0, our first term is n, and that's exactly what we want. And it's still equal to 1 minus r, where r is the ratio. Now, from there, okay, we have our index. We're trying to get an exponent of n on the ratio. And we have that for the denominator. The -2 is fine, but the numerator is n plus 1. So to fix that, we're just going to factor out a 3. And you can see that using exponent rules, n plus 1 is the same as, well, n plus 1. So this is equivalent statement. And then that's still over -2 to the n, summation n equals 0 to infinity. Alright, from there, we can clearly see that you can pull out the 3, and then write 3 over -2 to the n. When the numerator and denominator are raised to the same thing, we can just collectively group them as so. And then we see that, well, our a term, I just pulled it out of the summation, but it's just a constant. That would be our a. And then our ratio is 3 over -2. Now in absolute value, we can see that that's actually greater than or equal to 1, which means this series is getting bigger and bigger in absolute value as we progress through the terms, which means it diverges. Now if we had -2/3, that would be perfectly fine, and we can compute the limit of the partial sums and get a value, but in this case we're just saying it diverges, and that's the end of the problem.